Welcome to session 23, Domain, Range, Models, and Sequences. Today, you will state domain and range restrictions from rules and contexts, write arithmetic and geometric sequence rules, and select linear, quadratic, or exponential models from data patterns. Watch the structure, not just the arithmetic, because each move must preserve the meaning of the problem. The visual gives us the central idea. Compare vertical changes across equal horizontal intervals. The curve becomes steeper because outputs are multiplied by a constant factor rather than increased by a constant amount. This visual distinction matches constant ratios in a table. Use this first move. Apply algebraic restrictions. Denominators cannot be zero, and even roots need non-negative radicands. Then, apply contextual restrictions such as whole number counts and non-negative time. Worked example, domain restriction. State the domain restrictions of f(x) equals 5/(x2) and g(x) equals the square root of x plus 4. Step 1. For f, the denominator cannot be 0, so x is not equal to 2. Step 2. For g, the radicand must satisfy x plus 4 is greater than or equal to 0. Step 3. Therefore, g requires x is greater than or equal to minus 4. The final answer is f. X is not equal to 2. G. X is greater than or equal to minus 4. Check that it satisfies the original conditions and carries the correct units. Now it is your turn. Find an explicit rule for 7, 12, 17, 22, and so on. Pause, write each algebra step, and use the next 6 seconds to finish your solution. Here is the modeled solution. The answer is n equals 5 and plus 2. Use first term 7 and common difference 5. Verify it against the exact wording before moving on. Session 23 recap. Apply algebraic restrictions. Denominators cannot be 0, and even roots need non-negative radicands. Next, apply contextual restrictions such as whole number counts and non-negative time. Then, check first differences, second differences, and ratios in that order. Finally, write the selected rule and test it against multiple data points. A complete solution shows the reasoning, checks the result, and states what the answer means.